All right, starting the next unit. Just a reminder that before you start this unit, please make sure you finish the previous unit. Okay, that includes going through each of the lessons, doing the homework that is listed, and then once you're finished the unit, please try the practice test, and if you'd like me to mark it, please send it to me. Okay, it won't be for marks, but you want to know how well you're doing. Okay, make sure that's all done before you start this unit. All right, so this unit, solving quadratic inequalities. So there's the big difference from the previous unit. Last unit we talked about quadratic equalities, in other words, equations. If you remember what an inequality is, that's the greater than or less than signs. Okay? Before we do that, a quick refresher. If you see an equation like this, so here this is an equation, we are looking for what values of x will make this equation equal to 0. That's what this is saying. All right, and how did we solve that? Well, we usually factored. Factored's the most common method. Hopefully they usually will do that, will factor. Okay, and if we want to multiply to -6 and add to 13, I think that will work. Yeah, it does. And so 5x plus 2 equals 0, so 5x is -2, x is -2/5, and here x minus 3 equals 0, so x equals 3. And so you have two solutions. All right, we should remember how to do that. You're going to need that skill for this unit, because the inequalities, we're not going to be looking for where it equals 0, we're going to be looking for where it's less than or greater than 0. And the zeros are a good place to start. Okay, so let's take a look at what we're talking about here. A quadratic inequality. So either less than or greater than, less than or equal to, greater than or equal to. All right, in each case, we want to find out what are the values of x that make the statement true. Okay, so a quick little explanation of what this is asking. So here you have what we did last unit. It's a quadratic, and it's an equality. It equals. All right, and so if you graph that, you get this graph right here. This is the graph of that parabola. Okay, this parabola. To graph this, we knew what the vertex was, and we found the x-intercepts, and of course the y-intercept. That's what we would have done to graph it. So now let's take a look at this. This is an inequality. It's not an equality. We're not solving where does it equal 0. We're saying where is it greater than 0. Okay? So looking at our same parabola, because it is the same equation, where does it equal 0? Well, here's the two places where it equaled 0. But we want to know where is the parabola greater than 0. And what that means is where is y greater than 0. So that would be here and here. So when we're looking at this statement, we're looking at what are the x values that will make it so that the equation y is greater than 0. So the solutions would be here, these x values, and these x values, because when you pick, for example, this x value, what do you get for the graph? You get this value. Okay, so the solution for this inequality would be where is x less than -1, or where is it greater than 3? We're probably going to write it like this: -infinity to -1, or 3 to infinity. Okay, that means the same thing. All right, let's try another one. So here it's saying, where does this quadratic equation, where is it less than 0? In other words, where are the values? Where is y less than 0? Okay, well, here it's less than 0. So the question is, what is the solution? It's from here to here. What are the x values that will give us a y value less than 0? Okay, and we would write that from -1 to 3. By the way, why am I not using square brackets? Well, the reason I'm using round brackets is because it's only less than 0. It's not equal to 0. We will do ones where they're equal to 0. Okay? So, Normally, you're not going to graph the parabola for an inequality. There's a shortcut. And the shortcut is just looking at the x values on a number line. That's going to be the method we're going to use. So let's try an example. It says solve the inequality. Okay, solve the inequality. My first step is going to be to change this so that I write the quadratic part less than 0. So the question is, what x values will make this equation less than 0? Well, first thing you should consider is where is the equation equal to 0? Okay, so that we can do easily. We already know how to do this. We can factor. So it's equal to 0 at 1/3 and -1. So using that information, I'm going to make it a number line. Now I know there are other values on that number line, but these are the critical values. Okay, these are what we call the critical values. They're the values where it equals 0. Now what do we want? We want, where is it? Less than 0. So the question is our answer here, here, or here? And what we want to do is we want to figure out what the value is in those three intervals. We know what the value is right here and right here. Right here the values are 0. So I know that these other places are either going to be less than 0 or greater than 0. So let's try -2 from that interval. Okay, and the easiest place to try it is in the factored form. Whoops. What just happened there? All right, we're going to try this -2 into the factored form. Okay, if I put a -2 into the first one, now I don't care about the values. I'm going to write it out, but I don't care about the values. I just care, is it positive? I just care, is it positive or negative? So looking at this first bracket, 3 times -2 is -6. Take away 1, this is negative. And here, -2 plus 1, this is negative. What's negative times negative? It's positive. So I know that this interval here is positive. Everything up to -1 will give me a positive value. Is that what I wanted? No, I wanted less than 0, not greater than 0. So let's try a value in here. What's a value between -1 and 1/3? Well, 0 is probably the easiest one to try. So again, I'm going to put it into the two factored brackets. If I put a 0, I get 3 times 0 minus 1, so this would be negative. And 0 plus 1, this would be positive. What's negative times positive? Negative. That means this interval here, every value is negative. How do I know that? Well, because here it's 0 and here it's 0. And if you think about a parabola, if it's crossing at zeros, okay, it's going to be positive one side, it'd be every negative all the way in the middle, and then it would be positive on the other side. So I can probably guess this is going to be positive, but I should quickly check. Let's test a 1. If I put a 1 in there, I get positive, positive. Yes, so it's positive. Okay, so what have I figured out? Well, I wanted to know, back at this original question, where is it less than 0? Where is it less than 0? The solution will be anywhere from -1 to 1/3. All right, that's the solution for this inequality. Any value in that interval will work. Okay, let's try another one. So you can see that it doesn't look right. We again want to change this to an inequality where you have a 0 on one side. So let's take the negative 8x to the other side. And I'm going to FOIL this already. Oh, that's weird. So I have negative 3x squared plus 3, and then I'm adding the 8x. Sorry. Okay, so 0, negative 3x squared plus 8x plus 3. So quickly let's factor that. Think this is going to be, let's see, we want to multiply, so this has to be oh, that's not going to work. So I'm looking at that and thinking, wow, that's really hard to factor. I can't quite see it. Maybe I want to divide everything by a -1. And I'm actually going to do this for two reasons. I also want you to remember what happens when you divide an inequality by a negative. The sign switches direction. Okay. So now let's change this to an equality. And I think this is, at least for me, it's easier to factor this way. So I get 3x and x minus 3 plus 1. Okay, so my critical values, the x-intercepts, are -1/3 and 3. Let's put those on our number line. And I want to test some values because I want to know where is this entire inequality greater than 0? Where is it positive? Okay, so let's check. What could I check here? I could check -1. If I put it into the brackets, the factored form, I get -3 plus 1. This is going to be a negative. And -1 take away 3, that's -4. Again, it's going to be negative. So if I multiply, I get positive. So the interval here is positive. Okay, let's check a value in here. 0 is probably the easiest one to check. So what I'm doing is I'm putting a 0 in here. So 3 times 0 is 0 plus 1. This is positive. If I put a 0 here, 0 minus 3 is negative. So this will be negative. And then I can check here. Let's check a 4. What's going to happen if I put 4 in? It'll be positive, positive. So there are my intervals. Now what did I want again? I'm looking here. And I wanted, where is this entire thing greater than or equal to 0? Where is it greater than 0? Well, that means where is it positive? So my solution will be from -infinity all the way to -1/3, or 3 to infinity. How's that look? Well, there's a problem. Because in this inequality, it could be greater than or equal to. So I have to change these brackets to include those values because it would be okay to be 0. All right, now if you're thinking, well, I don't know, that doesn't quite look right, you could always check. Pick a value. So pick a value from this interval. Say 4. Let's put it back into the original equation. See what would happen. You would get -8 times 4, and you'd get -3 times 4 squared minus 1. This is -32. Is that greater than -3 times 15, which is -45? Is -32 greater than or equal to -45? Yes, it is. Okay, so this is our solution. All right, and that's the end of today's lesson. If you can try some of these, page 346, numbers 3 to 7, 11A and B, 12 to 14. All right, do that homework. check your answers. Remember to check your answers, see if you're doing well. There's no way for me to take a look at your work. If you're having trouble, please send me an email and we'll see what we can do about it.